Hello friends, it's MoNaCo here with our fifth notes video for homework, focusing on separation of matter. By the end of this lesson, you should be able to identify some separation techniques to separate simple mixtures of matter. I chose as a beginning lead-in a not so simple mixture of matter called crude oil. Crude oil is basically what America and the world is addicted to these days. It's being pumped out of the ground all over the United States. Alaska, South America, the Middle East, crude oil is incredibly important. But it's useless by itself because it's a mixture. In order to separate it into things that are useful, we as chemists and engineers have to do some physical separation techniques. And an industry that's called a fractioning column, where we are able to take that crude oil and separate it into all the things that we need from it, like bottled gas for our grills, gasoline, petrol for our vehicles, chemicals for the chemical industry, jet fuel for planes, diesel fuel for 18-wheelers and other transportation, lubricating oils like motor oil for all of our engines, fuel oil for shipping, container ships, as well as heating our homes, and bitumen, which is that really thick, black, tarry, nasty stuff that's used to make asphalt for roads and roofs over our heads. Okay? But all that stuff was inside crude oil, and it had to be broken down into its mixtures, or into its separate constituent components by separating it from its other materials. So our lead in here is, how could you separate a mixture of matter? Well, just like when you collect a bunch of different rocks or stones or pebbles or souvenirs from the beach, you can come home after they've all dried and separate them into little piles. Maybe the green beach glass, the blue beach glass, the brown beach glass from the little shark teeth and clam shells that you may have picked up as souvenirs. So our focus today is learning the different type of separation apparatuses, the type of separation that is done, and the types of mixture that each apparatus can be used to separate. Okay. In the interest of being able to read these, I am going to go to single screen here. So the first type of separation is a filtration. It is a physical separation. Okay. It's where undissolved particles remain stuck in a filter paper. This is like making coffee. Okay, coffee grounds go in the filter paper. You pour the water over the top. Obviously, it's hot water. The dissolved flavor from the coffee grounds and the hot water moves through the filter paper down into the mug. In chemistry, we do this with not coffee, but many, many, many other situations where we have to separate a simple heterogeneous mixture, like sand and water. Something that will dissolve in the water versus something that won't. Just scroll down here to an evaporation technique. Evaporation techniques are pretty straightforward. There's two ways to do it, and they're always physical. It's either a watch glass evaporation, where you use a burner and an evaporating dish with a watch glass over the top to literally heat up and drive off the stuff, the solvent that was dissolving the solute. I have a correction here. It's not the solute that's escaping, it's the solvent. Solvents do the dissolving, solutes get dissolved. These are not very good at being precise, evaporations that is, but it's capable of separating a homogeneous mixture, a solution, into the stuff that would evaporate away, usually the liquid, and the stuff that would not, the solid that got dissolved. So if you wanted to separate Kool-Aid that has been mixed back into the Kool-Aid powder and sugar, you would do an evaporation. Okay? A crucible evaporation is the same exact technique, just a slightly different apparatus. Okay? If you ever have to do one of these, you'll be given specific instructions in the laboratory setting on how to do that. Okay, going to the next page, a distillation is kind of an important type of process. Again, it is a physical separation. Okay? It separates the solutes from the solvents by boiling and recondensing in another receiving flask. This is kind of like a blown up version of what the crude oil fractioning column would be. The crude oil would be over here on the left hand side. It would boil out and small pieces would be collected in different beakers as it goes. This makes a homogeneous solution able to be separated. It can be removed It can be used to remove impurities from water. So if you've ever used or drank distilled water, it has gone through this process. A lot of the filtered or processed water that you buy in a bottle has gone through this distillation process in order to become purified and cleaned. It's capable of separating two or more liquids with different boiling points. Obviously, if the two things can boil at the same temperature, they're not going to be able to separate. It's one of them boils off and leaves like evaporation, but we collect the steam, and the other stays behind. That's what a distillation is. This is also used to make strong alcohol spirits, okay, aka liquor. The last type is a chromatography, and this is the only separation technique that is based upon chemically. Now, let's see, let's find the click. It's in here somewhere. There. No, it is a physical separation. I thought for a moment it was chemical. No, actually, now that I think about it, it's based upon molecular size and solubility, so that's physical. It separates particle based, again, on size and solubility, and it separates homogeneous mixtures. Chromatography you may have done in a living environment or biology class with chlorophyll to see the chlorophyll A and the chlorophyll B. Put a dot of ground up plant matter and dip it into a solvent, and what happens is this material will migrate, okay, and leave different colored, different sized bands of all the compounds that were inside of it, okay? Probably different colors as well. Okay. So the important thing about this lesson is to know those different techniques: filtration, evaporation, distillation, and chromatography. On the other hand, chemical separation requires reacting a sample with something else in order to turn into a completely different compound. Okay? So of all the stuff that exists, matter, there are pure substances and mixtures. Mixtures can be separated by physical processes into pure substances. So you got a mixture of all this stuff. It can be separated into, well, piles of just the red ones and just the green ones by physical separation techniques. Okay? So at this point, you should be able to identify a technique that can be used to separate homogeneous mixtures and heterogeneous mixtures based upon the compounds or elements that are mixed. Okay? Thanks very much. You'll get the chance to practice these when we get into them doing laboratories. Thank you.